Hey everyone, today we're going to keep moving forward with surds, and our goal today is to rationalize the denominator. Okay, if you want a title for today, it's Rationalizing the Denominator. But first of all, we've got some warm-ups. These are warm-up questions from our multiplying surds from last lesson. Please take the time now to pause this video, do these 3 problems for me and upload them in the corresponding place in OneNote so I can check that you're going okay. All right, moving into rationalizing the denominator. Guys, what that means is that we want to transform having an irrational denominator, for example, a surd. You may recall last term we talked about how surds were irrational numbers, into a rational denominator. And the reason we want to do that is so that if we have a rational number on the bottom, usually it helps simplify the way we're working out problems. So if that surd is part of a bigger problem, okay, then it's easy if we just have a rational denominator. So, in a general case, if we just have some number a, so it can be any number, divided by a surd, we would say this is not a rational denominator because we have an irrational number on the bottom. The process that we follow is we multiply by whatever the denominator is divided by the denominator again. What's really special about doing this is essentially the same as multiplying by 1 because, you know, if this was just a normal fraction, that root x on root x would just cancel out to be 1, right? So if we multiply by this, it actually doesn't change what we're doing at all. It's just the same as multiplying anything by 1. We're still going to have itself. But by rationalizing the denominator, if we follow our rules by multiplying fractions, on the top, we're now going to get a root x, and on the bottom, now remember that special rule last lesson and the lesson before and the lesson before that, if we have root a squared, which is just root a times root a, remember that's just a, yeah? So that means that if we have root x times root x on the bottom, we're just going to get x. So we can see that if we just have some general irrational denominator like this, by multiplying by whatever the denominator is over itself, using our multiplying by fractions rules, we end up with a rationalized denominator. So this x is now just a number. So it's a rational denominator. Let's do some examples of these. So if you would like to have a go based on that general case, please pause now and have a go. For part A, the first thing we're going to do is we're going to multiply by root 3 on root 3. Following our rules, we're going to have 2 times root 3, so 2 root 3 over 3, because remember, root 3 times root 3 is just 3. And that's our answer. That's it. Nothing else has to be done in this case. Let's have a look at B. With B, we're going to multiply by the denominator over the denominator. Whoops. Root 5 on root 5. So on the numerator, we end up with 3 root 2 root 5. We'll put those together in a moment. Over 5. So popping those surds on the top together, we get 3 root 10 on 5. Now in this case here, we don't have to simplify that root 10 because 10 has no square factors. But just watch that in future when you get to the textbook, you may be able to simplify as any surds on the top. And if you can, you must do that. Question C is a little bit more challenging. Take the time now and see if you can have a go at this, remembering that there's an invisible bracket on the top there, yeah? All right, let's do it. So we're going to multiply this by root 3 on 3. So that's just the same process that we've been doing. But I need to remember that when I multiply that numerator, I'm going to end up with root 3, 1 minus root 3. So I'm going to have to expand that in my next step. Over 3, because root 3 times root 3 is 3. Now I'm going to expand that numerator because I'm just trying to simplify it. Root 3, take root 3, which is simply root 3 minus 3 on 3. And no, it doesn't actually look simpler, but remember, we're not trying to simplify this. We're trying to rationalize the denominator, okay? So we've gone from having a root 3 on the denominator to now having a positive 3. And that's the goal. That's what we wanted to achieve. So I've got 2 more examples down here for you to have a go at. Please have a go now. We've got this one here, which is similar to B, and we have this one, which is similar to C. Upon checking your answers, you should find that you get, and pause now if you don't want a spoiler, 4 root 21 on 7, and root 2 root 7 take 7 on 7. And guys, to get some practice with this one, we're going to go to 3D. Just do A and D from questions 2 to 5. 3 questions, A, E, and I from question 6, or you can choose your own. And then we have our challenge questions down here, question 8 and question 12. If you have any questions, you know you can email me. Thanks, guys.